All right, this is Mr. Baker. Going to go through some things very quickly, so be ready to write. Remember, you can pause along the way. And once again, if you have any questions for Mrs. Clark or myself about regular math, please let us know. And don't forget about your IXL due Monday. Here is the homework from yesterday. We did the unit prices right activity. So as you were looking here, bag B is the better deal. It's 12 cents per ounce, and that means you're saving 18 cents per ounce when you purchase that way. You had to do rounding to the nearest cent. This one rounds to 96 cents per drumstick, and that's 75 cents per drumstick. This one's kind of an easy one to see. If I'm going to go from 4 to 8, that's just times 2. So if you just think about that, that's almost $3. If you bought 2 boxes, you'd only be paying about $6. And over here, you're paying $7.69. So you can see that you're clearly saving money by buying item B. 21 cents per drumstick, actually. As you look at the next one, this one rounds to be the same, 14 cents per ounce, but technically bag A, it's not an equal deal. Bag A would be the better deal because you're going to save, like 3/4 of a penny per ounce. And so in the long run, for us personally, it's not going to make a huge difference. But if you are buying, if you're buying lots and lots of bags, it's going to make a bigger difference over the time period. Number 3 was a little bit tricky because you had to worry about this buy 2, but it was 9 ounces. But technically, if you're buying 2 boxes, you're really getting 18 ounces. So $7 for 18 ounces is 39 cents per ounce, which is saving you 19 cents per ounce. So bag B is the better deal. You could also have interpreted this as, I know that's $3.50 per container then for 9 ounces, and you could have done it that way as well. As you look at the next one, number 5, option B is the better deal. You could have done it as waffles, or you could have done it as ounces. And so you can see that you're going to save 3 cents per waffle or 2 cents per ounce by doing option B. As you look at the next one, you have 42 cents per battery on the left and 60 cents per battery on the right. So you're going to save 18 cents per battery by buying the one on the left. As we look at the next question, we have 13 cents per ounce and 12 cents per ounce. So you're going to save 1% per ounce, but that's actually, you can actually see through multiplication. This was 150 ounces, and this was 50 ounces. And so if I wanted to go to 150 ounces, I would need 3 of these containers. Well, 6 times 3 is 18, so you can see you're going to save about $2 if you were to buy 3 containers, and you're going to get the same exact amount of detergent. So you can see that 1 cent makes a difference as you're dealing with bigger containers. Number 8, item B is a better deal. You're going to save 3 cents per diaper. And that leads us to my question here. So as I'm dealing with my children, I would be saving 3 cents per diaper if I bought option B. And I have 3 children, and each child was using 5 diapers a day, different parts of their life, obviously, so 5 diapers a day for 365 days a year for 3 years, and then that was 3 children. So 16,425 diapers, a little depressing. And I'm saving 3 cents per diaper, so that's $498 or $492.75 is what I would save over the long run. All right, so turn to page. We're going to begin notes. We're going to turn to page 3, and we're going to start talking about proportions today. Turn to page 3 in your note packet, and we're identifying proportional relationships today. So a proportion is an equation. So once again, it's going to have an equal sign stating that 2 ratios are equal. So for example, down here, we will know that these 2 are equal to each other because they both reduce down to 1 or 3 to 4, both of those ratios. When 2 ratios are equal to each other, they form a proportion, and therefore they are proportional to each other. So there are 3 ways in which we're going to determine whether or not 2 ratios form a proportion. You can use, unless the directions tell you otherwise, you can pretty much use any of the methods. But first method is simplest form. So we're going to look at 2 ratios, and on your homework tonight, it's going to basically say, I want you to put an equal sign, or I want you to put a not equal sign in each one of these. So the first way is we're going to simplify these ratios just like they're a fraction. And as I look at 12 and 18, I can divide both of these by 6. All right? And 12 divided by 6 is 2. 18 divided by 6 is 3. As I look at 50 and 75, yeah, lots of you will say it ends in a 0 and a 5. I can divide by 5. That's great. But think of quarters. I can divide by 25. And 50 divided by 25 is 2. 75 divided by 25 is 3. These two are equal, so they are going to be proportional. And so on your homework, you guys will get to put an equal sign in there. As we look at the next one, 10 and 12. Well, 2 goes into 10 and 12, so I'm going to divide both of these by 2. And 10 divided by 2 is 5. 12 divided by 2 is 6. As I look at the next one, lots of you struggle with, well, yeah, you can divide by 2, but that's not going to be a good choice. When I see 56, I automatically think 7 times 8. And 8 goes into 40, so I'm going to divide by 8. And 40 divided by 8 is 5. And 56 divided by 8 is 7. You can see that these are not equal, so therefore we would say they're not proportional to each other. As we look at the next section, this is a fast way. It doesn't always work out nice and pretty, but we call this the common multiplier method. And basically what we're looking at is as we look at these ratios, just like we're going to write a common denominator and we multiply, I'm going to multiply this 4 by 8 to get 32. I know that 4 times 8 is 32. Well, if I can multiply the bottom by 8, then it would be equivalent because 8 over 8 is 1. I just really multiplied it by 1. So in this case, 5 times 8 is 40, so therefore these are proportional. So you can use this common multiplier, and you can see that they'd be equal. In this case, I know that 7 times 4 is 28. Now, I don't care what 21 times, what I need to test for is, does 4 work here? Well, 21 times 4 is not going to give me 63. It's going to be in the 80s, actually 84, but it doesn't really matter what it equals. I know it doesn't work. So these are not equal to each other, so they're not proportional. Some of you are like, well, I know that 21 times 3 is 63. Well, then that means that's times 3 on the bottom and times 4 on the top, so therefore it's not proportional because you didn't multiply by the same thing. Now, this is a method that most of you are going to start using, and it is called cross products. And when you hear the word products, you are thinking about multiplication. So you're dealing with multiplication. So cross products, and think about things that cross. That would cross. And what I like to do is we go ahead and do 6 times 12 is 72, and 8 times 9 is 72. And those are equal to each other, so therefore they are proportional, because there is a rule that says if two ratios are proportional or equal to each other, then their cross products would also be equal. And so all you have to do is take your cross products, and if you're allowed to use a calculator, then that makes your life a whole lot easier, and you can quickly just do cross products instead of simplifying. And so in this case, I might have decimals, and so I go 8.2 times 7, and you get 57.4. And you're going to take your calculator out, and you're going to go 6.5 times 9, and that equals 58.5. These are not equal to each other, so therefore they're not proportional. And we've called this the Jimmy Neutron method. In my classroom, we'll watch a video. But because one of my students in the past, years ago, said, hey, Mr. Baker, this looks a lot like Jimmy Neutron's shirt. And that's the atom molecule, I believe, for you science people. And so I watch a video with Jimmy Neutron, and we call this the Jimmy Neutron method to remind you to cross multiply. Okay, so we could quickly go through these and use any method on these. Now I noticed that this is already in simplest form, so if I quickly simplified this, I could divide by 5. This would become 1/2, and you can see that they're equal, so therefore it's proportional. You could also have done cross products. You could have done common multiplier. That's times 5. This is times 5, so therefore it works. In this case, I quickly see that this is times 4. Well, 4 times 4 is not 18, so this is not proportional. Most of you are going to avoid simplest form because that's not always the easiest one for many of you, but you can use a calculator to do cross products. So in this case, I can look here and I go, this is dividing by 2, but over here this is times 2. So therefore, this is not proportional. Now you could also have done your cross products very quickly. And you could have done, oh, this is 60. See, my loop here is 60, and this is 15, and they're not equal to each other. And honestly, just looking at those two, that should have been pretty easy because this is an improper fraction and the other one was not an improper fraction. Therefore, they can't be equal to each other. All right, so in this case, doing a common multiplier, well, nothing pretty works into that. Doesn't mean it doesn't work. Okay, simplifying isn't a bad option. If you have a calculator, one of your best options is just do your 25 times your 12, and you get your 300. Okay, and then you go this way, and you go 20 times 15, and you get 300, and now you know that they are proportional. Okay, now they're not always written in the fraction form, and that's where we're headed right now. And so when we look at these are not written in fraction form, and what we have are two ratios. Now this is in word form. And so what you're going to want to do is we're going to put these like this, and I kind of add an extra little line out here to the side. And what I'm going to do is I'm going to put the label. So it's laps and minutes. And so what I'm going to do is I'm going to take my laps, 4 laps for this ratio, and 2.4 minutes. That's that first ratio. I'm going to look at the second ratio, and it's 16 laps, and it's 12 minutes. You sometimes have to be careful because they don't always use those nice, pretty, same order in the numbers, in the problem. So we go 4 times 4 is 16. Well, this times 4, if I go, that's 16, that's going to give me 9.6. It's not going to work. You could also have done cross products, so this is not proportional in this example. Okay, so once again, we kind of have a story problem almost. We're going to add an extra little line out here, and it says 20 pages of the books in 25 minutes. So I'm going to go pages and then minutes over here. So what that tells me is when I write it over here, I need to make sure I put my pages up on top, 20 versus 25. And on the right, I go 36 pages to 45 minutes. Okay, and once again, we're going to try to figure out if that's proportional. So quick, easy way would be to do your cross products. 45 times 2 is 90, and so it's 900. And if we do our 25 times 36, you also get 900, and those are equal. So therefore, even though you read different amounts, it is proportional. You're reading at the same pace the entire time. All right, the last section that we need to refer to are these wonderful tables, and we need to determine whether or not this is a proportional relationship. Now, quick, easy way is you could simplify every one of these. It's not necessarily, this is already in simplest form. I can divide both of these by 2, and it gives me 1 to 5. I can divide both of these by 3, and it gives me 1 to 5. And since those are all the same, that works, and it's proportional. I could also do cross products. I'll do it in a different color. So I can look here, and that's going to give me 10. And I multiply here, and that gives me 10. But I have to also look here. Well, that's 30, and this is 30. And so you can see that those cross products are also the same. So you can do cross products, but you have to be careful. Just because the first two work doesn't mean that the next two will work as well. All right, so as I look at this one, I could simplify quickly. Dividing by 2, I'd get 1 to 3. I can divide both of these by 4, and I get 1 to 2. Well, these are not equal, so it doesn't matter about anything else, and so this would be not proportional. Okay. Now, I could also go right here, and I could just do this. That's 16 with my cross products. That's 24, and you can see that those are not equal, so therefore I'm done. I don't even need to test anything else because if the first two ratios aren't equal, then it doesn't matter about the rest of it. All right, so apparently my paper did not show up. The homework paper is the proportion worksheet, and on the front you will be showing your work on how you proved it. It can be simplest form, it could be cross products, and you're going to be writing one of these two things, equal or not equal. You will submit it to Canvas when you're done, and then work on your IXL. If you have any questions, see Mr. Baker or Mrs. Kearns or Mrs. Clark, and have a wonderful day.